This is geometry, lesson 1-5, angle relationships, page 46. Yesterday, just a quick review of what we talked about yesterday. Yesterday we talked about adjacent angles. Adjacent angles are two angles that are side by side. They share a common vertex, they share a common side, and they have no interior points that are common. That's what we meant by adjacent. We talked a lot about adjacent, how different lines could be adjacent, segments, rays, they could be form that. So then we went to vertical lines, or vertical angles, excuse me. Remember, vertical angles are formed by two lines intersecting, correct? If you're a Husker fan, you throw the bones, vertical angles, okay? Opposite angles are congruent in vertical angles, okay? So you got to make sure that the lines are straight and the lines intersect before you get vertical. Then the last thing we talked about was complementary and supplementary angles. Complementary angles were two angles whose sum is equal to 90 degrees, and supplementary was two angles whose sum was equal to 180 degrees. Do you remember that? We talked about a linear pair of an angle which forms a straight line with two angles that form a straight line with 180 degrees. They're called a linear pair. That's where we left it. Okay. So the first question that I want, based on complementary and supplementary angles, is this question. Find the measure of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. Okay? So, are they comparing the larger angle? We're going to kind of use UPSI here. We're going to understand, plan, solve, and check. Okay? Are they comparing the larger angle to the smaller angle? Or are they comparing the smaller angle to the larger? What are they doing?
Larger to smaller.
They're doing larger to smaller. So we're going to let the smaller angle be x. So x equals the smaller angle. Does everybody understand it? We don't know what it is. We're just going to call it x. So now it says the larger angle is 12 more than twice the smaller. What does 12 mean? So we're looking at
degrees.
It means, what does 12 more mean? What operation?
Plus.
Plus. So 12 more than twice the smaller.
2x.
There you go. Now, if these are complementary angles, what do they add up to?
90.
90. So if I take this angle, Harper, x, and I add it to this angle, 12 plus 2x, this is the smaller, this is the larger, I get 90 degrees. You see how you get that equation?
Yeah.
All right, you might want to write that down because you can have something like this. All right, so x plus 2x is
3x.
3x plus 12 equals 90. And now I'm going to subtract 12 from both sides, correct? And I get 3x equals 78. Now is 78 divisible by 3?
Yes.
Yeah.
Yes. Add 7 plus 8 is 15. So we divide by 3. And I get x equals 26. Is that right?
Yeah.
Alright. So that's the smaller angle. So the smaller angle is equal to 26 degrees. How big is the larger angle? What are
So
2 with
12.
90 minus,
Minus 26.
Could I take 90 minus 26?
yeah.
Yes. Or I could take 12 plus 2 times 26. You can get the same thing. Those are 2 different
64.
ways. So 90, you got it?
64.
64? That is correct. You did that in your head that quick. Interesting.
What?
Good. Nothing? Nothing? Alright. Questions about that? Alright, let's jump to something new. Lines, segments, or rays that form right angles are perpendicular. And this is the symbol we use for perpendicular. We don't want to always spell perpendicular. Alright? We don't always want to spell perpendicular because it is a tough word to spell. It's P-E-R-P-E-N-D-I-C-U-L-A-R. Okay? Anytime that you form a right angle, it has to show it. And our book does a nice job of showing it in red. Now what you have here is you have a line AB perpendicular to a line segment. Okay, it doesn't say they bisect each other, or it doesn't say it bisects a segment, just says that they're perpendicular. If this angle is perpendicular, then we learned today that this one is vertical to it, so how big is this angle? It's 90 degrees also. Alright, so let's put that in there, it's 90 degrees also. So if this is 90 degrees and they form a straight line, how big is this angle?
90.
And this one? So if you have one right angle in two intersecting lines, all four of them are right. Yes, sir.
So on the first one, if you were to draw that, what would it look like?
The first one, if I was to
The
draw
first
it.
question that we did.
I would take two complementary angles, make one smaller than the other, right?
Oh, I see.
And I would say that this was x and this was
64.
12 plus 2x.
You write the equation back in there.
I was confused with the other angles.
Yep, there's two angles there because they're complementary. All right. Questions about perpendicular. On the bottom of page 48, turn to page 48, please. On the bottom of page 48. Just hand it to Dawson. Thank you.
Yeah, thank you.
Yeah, would you set that on my desk, Dawson? Okay, on page 48, let's take a look at down there at the key concept about perpendicular lines. Perpendicular lines intersect to form four right angles. Just said that. Perpendicular lines intersect to form congruent 8 adjacent angles. In other words, this angle and this angle are adjacent, they're congruent. This angle and this angle are congruent, they're adjacent. This angle and this angle are adjacent and congruent. This angle and this angle are congruent and adjacent. Okay? Harper, stay with me. Segments and rays can be perpendicular to lines or other line segments and rays. So it doesn't matter that it's just lines. Lines are perpendicular, but so can rays be perpendicular. So can segments be perpendicular. And then you can switch them. A segment can be perpendicular to a ray, and a ray can be perpendicular to a line. Okay? Just different concepts there. The right angle symbol in the figure indicates that lines are perpendicular. Folks, Hartford, if they don't have this symbol in there, you can't assume it's right. Okay? Alright. Let's take a look at this one.
It's a left angle.
Alright, I'm telling you, line PR is perpendicular to line SQ. That's what I'm telling you. I'm telling you that's true. So I could put a perpendicular symbol in here. Alright, if I can tell you, or I can put the symbol in either one, or I can do both. The question is how do you find X and Y? I want you to figure out how to find X and Y. So draw the picture and try to figure out how to do X and Y. Can anybody suggest something? And I could get started. Utan.
4y minus 2 is equal to 5x plus, is that 6?
Why?
Because if they're adjacent, then that means they're both,
They're not adjacent.
oh.
They're across from each other and they're not vertical. If they were vertical, they would be congruent. What does 4y minus 2 equal? 90.
Oh.
Doesn't it?
Oh,
Yeah.
that's right.
Yeah. Doesn't it equal 90? So we can do that. In fact, that's where you were going. So I can do plus and negative. Do you understand that, Harper, how it equals 90? What about you, Gigi? Jaws, you understand how it equals 90? Okay. So now I'm going to subtract a negative 2 from both sides. And I get 4y equals 92. Divide by 4, and I get y equals 23. Is that correct? So y equals 23. Now I don't have to put degrees because I found a value. If I was finding an angle, I would find degrees. But I just found y, the value of the variable of y. Does everybody understand it? Okay, so how do you find x though? I'm gonna go with you, Gigi.
5x plus 6 equals 90.
Okay, she says 5x plus 6 equals 90.
No.
Does it equal 90? Is that angle the whole thing?
Subtract
No.
2x.
No. It's
Plus.
5x plus 6 plus 2x equals 9.
All right.
Oh.
What happens is she was close. We got this angle, but then we need to add this little piece onto it, and then that all equals 90. Does that make sense, Joss? Okay, now we just solve. We add like terms. So we have 7x plus 6 equals 90. Subtract 6 from both sides. We get 7x equals 84. And we divide by 7, and I get x equals what? 12? So we found x and we found y. Yes, thing.
So if you want to know the angle of WTR,
WTR, yes.
so
I would put 12 back in for x, take 5 times x, which is 60, plus 6, which is 66 degrees.
so even if you didn't want to know S, T, W, or R, you would still find X first.
Yes.
Okay.
You have to find x in order to find any of the angles,
Oh, I see.
right? Unless I ask you STR, STR is just 90 degrees.
Yeah.
But if I ask you WTR or STW, you have to find x, correct?
Yep.
Okay. All right. Let's take a look at this picture right here. I want to tell you things you can assume and not assume, because that really gets students in trouble, okay? And if you're looking, it's on the bottom of page 49. It's on the bottom of page 49. And on the left-hand column is things you can assume, and on the right-hand column is things you can't assume. First of all, you can assume that all these points are coplanar. All these points lie in the same plane. You can assume that, okay? I don't know if you remember coplanar, but coplanar means they lie on the same plane. All right? The second thing you can assume is that G, H, and J are collinear. They are on the same line. So you can assume that, okay? Then you can assume that ray HM, ray HM, ray HL, ray HK, and line GJ all intersect at H. You can assume that. So these three rays and this line intersect at H.
Yeah.
You can also assume that H is between G and J. H is between G and J. You can also assume that L is in the interior of angle MHL. Nope,
MHK.
MHK. L is in the interior of it. MHK, L is in the middle of it. And then GHM, GHM, and MHL are adjacent angles. So these two are adjacent. And you can assume that GHL and LJ or LHJ are linear pairs. So this angle here and this angle here form a straight line, so they're linear pair. And you can assume that this angle and this angle are supplementary because they form a linear pair. Those are the things you can assume. Now what you can't assume is more of an issue. Number one, you can't assume that there are perpendicular lines. You can't assume that this is a right angle because it's not shown. So there are no perpendicular lines. You can't assume that. You can't assume that there are any congruent angles. I know these two look congruent, but you can't assume it. These two look congruent, but you can't assume it. Not unless they're marked. There are no segments that are congruent. You can't assume that HJ is congruent to HK, is congruent to HL, any of those. You can't assume they're congruent. So those are the things you can assume. Do you understand that?
Yeah.
Yes, sir.
So I remember like in like second grade we were talking about like right angles and stuff, and if they didn't show like the box, you could like put a piece of paper up to the corner and just assume.
Yeah, you can't do that anymore. Nope, you can't do that anymore. Not unless somebody tells you it.
Right.
Okay? All right, that's a good point. All right, would you turn to page 51, please? 51. Okay, we're going to start with number 8 on page 51. 8.
Eight to 34.
You ready? You got your assignment paper out?
Got it.
All right, number 8. The directions say name an angle or an angle pair that satisfies each condition. Number 8. Take a look at the picture there. it says two adjacent angles. So they just want you to list two adjacent angles. All right? Two adjacent angles. Bo, we'll start with you.
FDG.
Angle
Angle.
FDG. Okay. FDG, okay?
And angle DGE.
Nope. Not, you said it wrong. FDG and angle,
DGE.
no,
GDG.
EDG.
What's it?
You gotta have the same vertex.
Oh.
So D has to be in the middle of both of them, right, Bo?
Yep.
Alright. So he said angle FDG and angle EDG.
Okay.
Okay? Notice how D is in the middle of both of them. Name two acute vertical angles. Two acute vertical angles. We're going to go to you, Harper. Two acute vertical angles. That means less than 90 degrees.
Okay. CAD angle C
Hold it. CAD. Okay.
and angle DCH.
D.
DCH?
Yeah.
Yeah.
No, those are not vertical.
Vertical. You said a key.
I want vertical.
Wait. Too acute.
I'll start you off. Alright? Angle BFC. Angle BFC. Write that down so you can see it. Angle BFC. What's vertical to it?
Angle.
Make sure you're using angle symbols.
Just vertical.
Cross from each other.
F.
Nope, don't say it, Utan. Let him do it.
ABD.
Nope. I said angle BFC or CBF. Which one did I say?
BFC.
BFC. I said angle BFC. This angle right here. What's vertical with it? Point to it. What's across from it?
This one.
This angle here is across from it. How do you name that angle?
Angle FDG.
No, you don't start with F. That's the vertex.
DFG.
DFG. Angle DFG. Did everybody see
I
that?
see.
Angle DFG is vertical.
That's like a butter.
You gotta look at it to where it has the same vertex.
Now,
Okay, I did not understand that.
Neither do I.
is what's that?
It's a
It
lot.
sort of forms like a butterfly, like the two triangles, like.
Okay, but it's not like gonna be like that.
Isn't like this?
No, it's not. I don't see it like that.
I
Okay.
see how they're across from each other.
Okay, so this is F, right? What's this point?
That's
B.
B, and what's this?
C.
C?
Yep.
What's this?
It's a flat line, straight line.
Oh, that should have been. It's
I
like.
think you told me wrong. Let's take a look here. Alright, this is C, FB, this is
D.
D, okay, it's a flat line, but it still is D. And then this could be G or
E.
E, it doesn't matter, right? But that, yeah, see how these are across from each other? This angle and this angle? It's like a bow tie, right?
That makes me think of horizontal,
Yeah.
not vertical.
No,
Vertical's on top of each other.
no, vertical is across from each other. They form scissors, okay? They form scissors.
But if you're vertical,
See?
vertical's this. Vertical's up and down.
This angle and this angle, or this angle. Yeah, these two could be vertical too, but they're not acute. They're obtuse.
So vertical either means up or down or side by side.
Side by side or up or down. It could be either
So
pair.
there's no horizontal, it's all vertical.
Oh, well, I don't know what you mean by that. So I'm not gonna say yes or no.
Well, I would
It sounds
think,
like a trap.
I would think the ones you just said were horizontal.
Okay, no, there's vertical. These, I see what you're saying. You're getting, it can be any way. It can be like, this and this, okay? It can be sideways too. This is vertical with this, and this is vertical with that. Okay, vertical is just across from each other. Doesn't mean up and down.
Oh, okay.
Okay, vertical has different meanings. In geometry, there are different definitions. I see what you're saying now. Okay, let's take a look at the next one. Now we're gonna go to obtuse vertical angle. So now we're gonna do the vertical angle thing again, only it's gonna be obtuse. Utan, I'm gonna pick on Jaws if you don't mind.
Okay.
Okay.
Ooh.
Okay.
You want me to start you out? Or you got it?
I'm gonna look one more second.
Bless you.
Bless you.
Start it off.
Okay, angle BFD. Angle BFD.
CF, angle CFE.
It's angle CFE. That is correct.
Could you go CFG?
You could go CFG also. Same angle. Yep.
Okay.
All right, now you're catching on.
Wait,
Now-
so
Well,
angles.
There's gonna be so many different
CF.
answers.
G.
Okay.
But do they all have to keep the same
Vertex.
Vertex.
vertex?
Yes.
Okay.
And so F was in the middle on both of our angles.
Oh, so you
Yeah.
can't just go find random different
No.
ones that are just
No. They have to have the same vertex.
Wait,
Greeley.
could-
So could we have done angle BGD? and angle-
BGD, yep.
And then angle BGH?
Yes, you could have.
What about angle FGD and angle,
FGD, yep.
and angle H?
GE, yep, that's the one she just said.
Oh,
Yep.
that's what you said.
I just
Yep.
used B instead of F.
Yep, but it's okay.
Come on.
Yep, you're the same. No, it's fine. Bo, that was good.
Country number 11.
Yeah, two complementary adjacent angles.
So-
Two complementary adjacent angles,
So
okay?
they are
have
on
to
the
form
same
90
line.
degrees.
They have to form 90 degrees. So Bo,
Both.
So FDG
FDG, yes,
and FD, or no, GDE.
yes. FDG, GDE. And make sure you're using your angle symbols, right? All right. All right, let's keep going, man. We're on a roll here.
1 minute, let me.
All right, we'll wait. FDG. Look at it. Look at it. Don't just say the letters. It does you no good.
I saw it, yeah.
FDG and then GDE. Mhm.
Oh. Okay, got it.
All right. One more. Two complementary non-adjacent angles. Two complementary non-adjacent angles. So they cannot be adjacent. They cannot be side by side,
They
but they're
have to be the same
complementary.
line.
So they have to add up to 90 degrees, and they can't be side by side.
Oh.
Now look at they got some angle measures there.
So 60 plus 30 equals 90. I
That-
see.
yeah.
I
That's
have
right.
both those angles. I just need to figure out.
Okay.
So
ABE
they can't be.
Okay.
and CBS.
So ABE is not one of them. No.
Oh.
BCF.
BCF is. That's the 60 degree angle. BCEF. What's the 30?
AE.
BA what?
E.
E. Or could I have BAD? Either one, right?
Could you
No,
have,
I thought you couldn't.
Yeah, you can. You can take either of those points.
Oh,
Okay, Bo.
could you have BFC and?
No, BFC. You don't know how big BFC is. BFC is that middle angle. F, remember, F is where your angle's at.
Oh.
And you want BCF. You guys, you can't just throw those letters out. The vertex is huge. It has to be in the middle. It's where you're going.
BAD or BAE?
and BCF. So they
Okay.
can't have the same vertex.
They gotta have the same vertex.
Oh, they
But
do?
wait,
Yes.
But
You
they're
just-
non.
No. I mean, no, you're right. They do not have to have the same vertex. What I'm saying is, you have to have the vertex in the middle.
Yeah.
What is going on here?
Just wanted.
Okay, we're gonna jump down to number 19 through 24. It says find the variable of each, find the value of each variable. All right, let's take a look at 19. 19, what kind of angles are, what they have measured there with the measurement? What kind of angles are those?
Obtuse.
Supplementary.
Nope.
Obtuse.
Nope. The 120 degrees and the 2x minus 10.
Complementary.
No.
Obtuse.
Supplementary adjacent.
No.
Vertical.
They're vertical, which means they're, I can't hear you, they're yelling stuff, I can't hear you. Okay, so what kind of equation do I set up to solve for x?
2x plus negative 10 equals 120.
Right, 2x plus a negative 10 equals 120. That is correct. Now let's take a look at 20. Let me draw it. We don't have a bunch of yellers now.
Wait a minute. 2x plus negative 10 equals.
Is that all?
We have to solve it. let's take a look at this one. Are they vertical, yes or no?
Yep.
Yes.
No,
Yeah.
they're adjacent.
They're adjacent, they're not vertical. Verticals are cross from each other, adjacent is side by side.
Okay.
They're adjacent. So I cannot set them equal to each other because one is clearly bigger than the other one. So how do I get an equation from this?
Oh.
Jaws.
2x plus 4x plus 108 equals 180.
That is correct. If I take this angle plus this angle, and I set them equal to 180 because they form a straight line. Alright, this is the first angle, this is the second angle. So if I add these are like, this is 6x plus 108 equals 180. Now I'm going to subtract 108 from both sides.
72.
So I get 6x equals 72. And divide by 6, I get x equals,
9.
no, I don't think so.
No. It's like
No.
12.
Thank you. Alright,
Degrees?
nope, because you're just solving for a variable. If you're solving for an angle, then it's the degrees. But you're just solving for a variable. Alright, let's take a look at, yes sir.
So are the 4x plus 108, is the angle that's vertical from that equal to that?
Yes, these two are equal, and these two are equal. Harper,
I see
these
that.
two are equal, these
Yeah.
two are equal. Okay? Alright. Let's take a look at 24 and then we'll be quiet. You'll notice that every single time I draw a picture, it's not for my help. I cannot see things unless I draw a picture. This is 5x plus 4 degrees. This is 3x minus 24 degrees. Okay, this is 2y degrees. See how they arrowed that in?
Yeah.
And this is 114 degrees.
They
So-
did that on 18.
They're messing with your concept of vertical here, okay?
It's vertical.
Uh, tell me about this angle, this angle, and this angle.
They all,
They add up to 180, right? But I got two variables, don't I? So I can't just set them equal to 180. How big is this angle?
2y.
2y. How big is this angle?
3x minus 24.
3x minus 24.
how do you know that?
Because it's vertical.
Vertical, they're right.
This straight line.
Ah,
So what I have to do is come up with, okay, is 114 equal to this angle?
yeah.
Yeah.
Ah, so I can do 5x plus 4 equals 114. I can do that because they're vertical, right? They form, two straight lines form them, right? So let's get that. We're gonna subtract 4. So I get 5x equals 110, correct? Divide by 5, I get x equals, how much?
27.
21.
27. Or 22.
That's 9 plus 10.
It's 22.
22. Alright. So x is 22, correct? How can we use that?
Plug it in.
Plug it into what?
X.
Plug it into x where?
All.
3x
Anywhere,
minus
right?
24.
3 times 22.
Alright, could I could plug it in for this?
Yep.
Okay, so let's plug it in for this. So 3 times 22 minus 24 is what, 66
66.
minus 24?
Negative.
It's not negative 2, it'd be 42, correct?
Mhm.
So this angle here is 42 degrees, right?
So that one's 42 degrees. Across.
So this is 42. However, could I, remember what I started with, could I take this angle, and this angle, add them up, and set it equal to
180.
180?
But and you don't know 2y, right?
I don't know 2y,
Okay, yeah.
but I do know this now.
Yeah,
42
fine, fine.
plus 2y equals 180, and I'll let you finish that. Okay? You're gonna add the 114 and the 42 and then subtract it from both sides and divide by 2. Okay. Your assignment is page 54,
That's up there.
54, 20 through 25. No, I'm sorry, I'm looking at the wrong class.
I had it
It's
written
already
down.
up there.
It was already up there.
8 through 34.
Thank you. Page 51, 8 through 34.
8 through 20, yeah.
There you go. 8 through 34, that's correct. All right, that is due tomorrow. So I'm gonna shut up and let you work. All right, we got quite a few of them done.
So then what Y is our answer on that one?
You can find Y and X,
Can I
yes.
stop the video?
What's that?
Can we stop the video?
Yes.